The method to do this is to perform U substitution, because U substitution will help us to reduce this formula. But what kind of U substitution? The answer is trigonometry substitution. We know some trigonometry identity that can help us to reduce this equation. So some of the trigonometry identity that we have learned previously is sine squared theta plus cosine squared theta is equals to 1. This is the identity that we can use, but we can always divide this identity by sine or cosine to change the identity to something that we wanted. So for example, if I divide this entire identity by sine, we'll get 1 plus cotangent squared theta is equals to cosecant squared theta. And if we divide this identity by cosine square, we will get tangent squared theta plus 1 equals to secant squared theta. So this is the equation that we can use for the U substitution. If we compare the equation, we get 1 plus tangent square, and this can be substituted into secant square. So given this 1 plus x squared in the denominator, we'll just let U to be equals to tangent theta. So let's write on the board, let U to be tangent theta. So with U equals to tangent theta, we can find du to be secant squared theta d theta. So from here, the dx term will replace this dx term, and the x term will be replaced by the tangent theta. So we just do the replacement. We'll get tangent squared theta, and we'll have secant squared theta. That will be replaced. The rest will remain the same. And this will be the replaced term. What do we do with 1 plus tangent square? 1 plus tangent square is this secant squared theta. So we can just replace it, and the integration can be simplified further. Secant squared theta over secant squared theta square d theta. Now we have this equation. We can cancel off the secant square in the numerator to become 1 and remove the square term here. So we get 1 over secant square, and 1 over secant square is none other than cosine square theta. So the integration doesn't change. We just integrate this thing. To integrate cosine square, we can reduce the power, and the formula that we can use over here is that cosine square theta is equals to 1 plus cos 2 theta over 2. And we'll just apply this formula and replace the cosine square theta with this formula over here. So cosine square theta, we'll just change it into this form. And the integration will remain the same. Right now, we can integrate one term by one term to solve for this equation. So the half will remain, and we'll integrate 1, we'll get theta. And integrate cosine 2 theta, we'll get half sine 2 theta. And not forgetting the plus c. We can't leave the answers in this form because we are supposed to leave the answer in terms of x. So how do we convert theta back into x? First, we know that we let x is equals to tangent theta. So we can draw a triangle to find out what is x. So we can draw a triangle here and we label theta. Right now, where is 1? Where is x? So tangent is opposite over adjacent. So opposite will have x and 1. So we get opposite over adjacent. Right now, what's the hypotenuse? hypotenuse is x squared plus 1 and the square root. So this is using Pythagoras theorem to get the hypotenuse. Now we have these three sides. We will be able to find sine theta and cosine theta. So what is sine theta here? So sine theta is opposite over hypotenuse, x over x squared plus 1 and the square root. Cosine theta will be 1 over x squared plus 1, and then there will be this square root. And tangent theta is just x. Okay, now we can replace all these things. Since tangent theta is x, we know that theta will be the arctangent of x. So now we can replace this theta with arctangent x. And sine 2 theta, how do we replace it? We'll just use another trigonometry identity to do this replacement. So sine 2 theta is equals to 2 sine theta cos theta. So we'll just calculate what is 2 sine theta cos theta. We'll just replace all this information over here to here. So we have x squared plus 1. And we multiply them together. Now the denominator, we can multiply them. Numerator, we also can multiply them. So now we'll have x squared plus 1 x. So this is sine 2 theta. Now to solve for this equation, we'll just replace everything. And now we will have the answer to be half tangent inverse x plus this half and this 2 will cancel one another. And then we will have x over x squared plus 1 plus c. Now this will be the final answer for this integration. Hopefully you understand how to do this trigonometry substitution for this U substitution portion.